This was tested in 2006, paper 2, number 20, and we are told two integers x and y are selected at random from integers 1 to 8. If the same integer may be selected twice, find the probability that Roman number 1, the magnitude of x minus y is equals to 2. Roman number 2, the magnitude of x minus y is 5 or more. And Roman number 3, x greater than y. Find the probabilities. Part B, a die is biased so that when tossed, the probability of number r showing up is given by p into bracket r is equals to kr, where k is a constant and r is 1, 2, 3, 4, 5, and 6, the number on the faces of the die. Find the value of k. Roman number 2, if the die is tossed twice, calculate the probability that the total score is 11. We have, I'll separate this question into two because part A and B are not related, and also to serve me in my space. For part A, you can get these probabilities by drawing a table where you have horizontals and verticals, and you enter the numbers 1 to 8. You can separate here and say that is your x, this is your y. So this is your x is 1, 2, 3. You put up to 8. Y is 1, 2, 3. Go on up to 8. Then you can fill. For example, 1 minus, let's use this as our y, and that is our x. 1 minus 1 is 0. 1 minus 2 is minus 1, but because it is magnitude, we ignore the negative sign. 1 minus 3 is 2. You ignore the negative sign. You continue like this. So this is 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 is 1. So once you fill that table, then you'll be able to answer this question, whereby you identify the values of x minus y is equals to 2. You get all the values where in our table where the difference is 2. Also with the same case with the second part and also the third part. For part B, then you are told the probability of getting r is equals to kr, and since you are given kr is equals to 1, 2, 3, 4, 5, and 6, then you can be able to calculate the probability. For example, for 1, probability of getting 1 is equals to 1 times k. That will give you not r but rather k. Then we have probability of getting 2 is equals to 2k. So once you continue like that up to probability of getting 6, which will give you 6k, then you note that when you add all this probability, they should add up to 1, because probability ranges from 0 up to 1. Then you'll be able to find the value of k, and with that you also be able to get the probability of getting a total score of 11, because you have only 5 and 6 add up to 11. So you'll be able to get these probabilities. So let's work out that question and see what we get. So in this part, since we are told that the integers were selected from 1 to 8, then we need to have already inserted my table for my convenience. But when you are doing it, you can just use your free hand to draw the table so that you save time. So we are going to put our x there, and this is our y. So this is 1, 2, 3, 4, 5, 6, 7, and 8. Then the y, 1, 2, 3, 4, 5, 6, 7, and 8. So we now have our integers. So because we need to get the magnitude of x minus y is equals to 2, so 1 minus 1 is 0, or 1 minus 2 is 1, because it is the magnitude. You ignore the negative sign. This becomes 2. 1 minus 4 is 3. You get 4, 5, 6, and 7. So 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 is 1. 2 minus 4 is 2. So you can see there is a pattern. You can just fill the table. So this is 5. This is 6. This is 3 minus 1 is 2. 1, 0, 1, 2, 3, 4, 5. So 4 minus 1 is 3. We have 2. We have 1. We have 0. We have 1, 2, 3, and 4. 5 minus 1 is 4. So this is 3. This is 2. This is 1. This is 0. Then we have 1, 2, and 3. So this is 5. This is 6. This is 7. This is let's correct that. So this is 5. So this is 4. So this is 3. This is 2, 1, 0, 1, and 2. So this is 7 minus 1 is 6. 5, 4, 3, 2, 1, 0, 1. 8 minus 1 is 7. 6, 5, 4, 3, 2, 1, and finally we have 0. So with that, we can now be able to answer Roman number 1, and we say x minus y is 2. So if you count the total number, that is 1, 2, from 0, we have, excluding the values of x and y, they all total to 64. The number of 2, we have, that is 1. This is 2, 3, 4, 5, 6. Then we have 7, 8, 9, 10, 11, and 12. So you find that x minus is 2. We have 12 of them out of 64, which you can simplify by 3. By 4 you get 3. Divide by 64 divided by 4, you get 16. So that is Roman number 1. We come to Roman number 2. Roman number 2, we say x minus y is 5 or more. So we take the values which are 5 or more. So that is 1. This is 2, 3, 4, 5, and 6. And on the other side, 7, we have 8, we have 9, 10, 11, and 12. So they are 12 out of 64, which should also give you 3 over 16. So that is the Roman number 3. Roman number 2. Then we go to Roman number 3. So here we now need to work out this x greater than y. So the values start from here, from 2. We have 2 is greater than 1. So all these values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So these are 28 out of 64, which when you simplify, you divide by 4, you get 7. Divide by 4, you get 16. So these are the answers for the first part of that question. So from there, we now go to the second part of the question. I hope you have followed what we have done. So part B, we are given that the probability of a number showing up is given by P into bracket R is equals to KR. And here we have been given R is equals to 1, 2, 3, 4, 5, and 6. And therefore the probability of getting 1 is equals to 1 times K, or K times 1, which is K. Probability of getting 2 is equals to 2 times K, which will give you 2K. Probability of getting 3 is equals to 3K, 3 times K. Probability of getting 4 is equals to 4K. Probability of getting 5 is equals to 5 times K, that is 5K. Probability of getting 6 is equals to 6K. All this probability, because if you add them, they should add up to 1, and therefore K plus 2K plus 3K plus 4K plus 5K plus 6K should equals to 1. When you add up all this K, you find that these are 21K is equals to 1, and therefore K is equals to 1 divided by 21. So that is the value of K. Then probability that when the die is tossed twice, that is Roman number 2, the total is 11. So probability total is equals to 11 is equals to, since we have the only numbers that give us 11 are 5 and 6, so this is a probability of getting a 5 and a 6, or probability of getting a 6 and a 5. So this probability, the probability of which gives us probability of getting 5 multiplied by probability of getting 6 plus probability of getting 5 multiplied by probability of this is a probability of getting 6, probability of getting 5, and this probability of getting 5 is 5 over 21. Since we have found that K is 21, you multiply by 6 divided by 21, then you add to 6 divided by 21, multiply by 5 divided by 21. When you get this, this is you can simplify here and say this is 7 by 3, this is 2, so that should give you 10. Multiply 21 by 7, you get 147, plus the same applies, you divide by 3, you get 2, divide by 7, you get, or divide by 3, you get 7, plus 10 divided by 147, that should give you 20 divided by 147. So that is the answer for that question, and that is how you work it out. I hope you have followed the whole process, and given similar question, you just do it the way we have done that. So thank you for watching. This is Teacher Mta Creations. You can get me through the number showing on the screen, or you can get me through WhatsApp with the same number. or you can get me in Facebook, Teacher wa Mtaa. If you have any question, any inquiries, you are all welcome.